Hello, everyone. My name is Rodrigo, and today I will be presenting our new work called LA-VocE, Low SNR Audiovisual Speech Enhancement using Neural Vocoders. This paper is the result of a collaboration between Imperial College and Meta, and was my main project during my internship at the company. Audiovisual speech enhancements, typically referred to as AVSE, aims to denoise the speech signal by receiving noisy audio and video of the speaker's face as input and trying to extract the original clean speech. This can be seen as a variation of audio-only speech enhancements that also leverages the speaker's lip movements to improve the quality and intelligibility of the reconstructed speech. This setup is particularly promising since we can make our own data by leveraging unlabeled audiovisual speech and mixing it with noise on the fly during training, enabling us to scale to very large datasets without having to worry about manual labeling. In practice, audiovisual speech enhancements can be useful in a variety of impactful applications, such as denoising speech in recorded lectures or live video calls. Before describing our method, let's quickly go through some examples of past literature in AVSE. On the left, we can see Visual-VocE, an audiovisual speech separation framework proposed in 2021. And on the right, we can see Muse, an audiovisual speech enhancement model proposed in 2020. We can see that both models are in fact rather similar. They start with an autoencoder that receives noisy audio and outputs clean speech, inspired by existing works in audio-only speech enhancement. Then, they add a visual stream adapted from existing lip-reading works and concatenate the resulting visual features with the acoustic features in the autoencoder's bottleneck. These methods suffer from two major limitations. Firstly, by treating visual speech as a mere addition to the audio pipeline, they fail to leverage state-of-the-art audiovisual encoders, such as the transformer-based architectures that have recently been proposed for audiovisual speech recognition. Secondly, both of these methods apply a mask on the noisy audio, which aims to block out the added noise, which works well when the signal-to-noise ratio is high, but becomes less viable when the noise is substantially louder than the original speech. Our method aims to address these limitations by proposing a two-stage approach that we call LA-VocE. In the first stage, we propose an audiovisual spectrogram enhancer, which starts by encoding the video using a Resonate 18, as usual, and encoding the audio using a single linear layer. Both features are then concatenated and fed into a 12-layer transformer encoder, which is responsible for audiovisual fusion and predicts the enhanced spectrogram via a simple projection layer. In stage 2, we adapt Hi-Fi GAN, a state-of-the-art neural vocoder, to synthesize waveform from clean spectrograms on the same corpus. This convolutional generator is trained using multiple discriminators via the least squares GAN loss, as well as an L1 loss on the MEL spectrograms of the real and generated waveforms. Finally, during inference, we combine these two models to perform end-to-end enhancement from raw video and noisy audio to clean waveform. We train and evaluate our model on AV Speech, which is known as one of the largest publicly available audiovisual speech datasets, containing around 4,700 hours of video extracted from YouTube. It features 11 plus languages and more than 150,000 speakers, amounting to more than 2 million clips in total. To add noise, we use the DNS Challenge Noise dataset, which was originally proposed for the Deep Noise Suppression Challenge in Interspeech 2020. It contains around 70,000 noise clips spanning more than 150 classes, which range from car noises to background music. It is worth mentioning that AV Speech is also used to add background speech that is overlaid on top of the original clean speech. We refer to this type of interference as interfering speech. We now move on to our results. As mentioned in our title, we focus on low SNR scenarios, that is, scenarios where the interfering noise is in fact louder than the original clean speech, making the enhancement task much more challenging. For our comparison with other works, we present 3 different noise conditions, ranging from least to most noisy. We measure the improvement between noisy and enhanced audio on multiple established metrics, such as PESC and STOI, and find that, while other methods achieve substantial improvements, LA-VocE clearly achieves state-of-the-art performance for all noise conditions. In particular, as we increase the level of noise, we can see the competing methods begin yielding substantially lower improvements, while LA-VocE is still able to yield noticeable improvements on all metrics, even in condition 3. It is also worth highlighting that audio-only methods, including an audio-only version of our own method, yield very low performance across all experiments, highlighting the importance of the visual stream. We present a short demo of our work, comparing it to other approaches on noise condition 2. Hello, everyone. My name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancements entitled LA-VocE. It's pronounced La Voce, which means the voice in Italian.
Mi chiamo Leonardo, sono uno studente di ingegneria, attualmente sto facendo la mia tesi e gioco a tennis, ho 25 sono uno studente tennis, ho
Hello, everyone. My name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancement entitled LA-VocE. It's pronounced La Voce, which means the voice in Italian. Everyone, my name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancement entitled La Voce. It's pronounced La Voce, which means the voice in Italian. Hello, everyone. My name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancement entitled La Voce. It's pronounced La Voce, which means the voice in Italian. Hello, everyone. My name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancement entitled La Voce. It's pronounced La Voce, which means the voice in Italian. Hello, everyone. My name is Rodrigo, and I'm the first author in our new collaboration on audiovisual speech enhancement entitled La Voce. It's pronounced La Voce, which means the voice in Italian. As we can see, despite still having room for improvement, La Voce clearly outperforms other models at removing background noise and interfering speech in this challenging scenario. In conclusion, we have presented La Voce, an audiovisual speech enhancement model that achieves state-of-the-art results for low SNR scenarios. You can visit our project page by scanning the QR code on the left, where you will find more demos of our work. You can also read our full paper, which includes more ablation studies and a more detailed analysis of our results. Thank you very much for watching our presentation, and have a great conference.